Welcome to Complexity Made Simple. My name is Paul Allen, and the subject of today's video newsletter, well, we're going to answer a query about statistical process control and a measurement system that only measures in whole numbers. Is that going to be okay? Especially for the IMR and the X bar R. So it's an SPC problem. It's also a measurement system problem. So we're going to put those two together and see if we can answer a question related to measuring whole numbers only. And the good news for the person who's asked this question is it's going to be okay, I think, but let's go through the technicalities and I'll answer the question. So I've got an email here. It just says, if you've got time, I have a question regarding SPC, specifically the IMR and X bar R charts for integer values, in other words, whole numbers. I'm looking to implement these charts to monitor a final test in production. The final test is a leak test and it measures, looks like kilopascals, kPa is what it measures, which inherently deals with continuous data. But unfortunately, the test machine they have rounds up or down, and therefore the measurement always comes out in whole numbers. And is this going to be okay for implementing SPC? Now, the important bit of information that you give me on this is most of the values fall within the range of -10 to +5. And then he says, is it possible to use the charts because the observations aren't really continuous, they're integer values, they're whole numbers. So let's talk about the issue of really a measurement system problem and whole numbers and whether that's acceptable or not. Okay, now you have to think what an SPC chart is going to do. It's going to work out the natural region of behavior. So these are called natural limits. If you were using true continuous data, of course, they're not going to land on a whole number. And even if you've got integer values, I often do an exercise with dice. And obviously they're integer values. And we work out control limits for a dice. And of course they land approximately at 1, approximately at 6. But they are approximate. They're still in fractional values. Okay? And obviously you've got the average through the middle here. You've got your upper limit. You've got your lower limit. Now the question about your measurement system and the chart is, will the whole numbers interfere with the chart working correctly? Now here's when it would interfere. If your measurement system, let's say, was averaging 0, so we're stuck at 0. Now looking at the results there, we're not stuck at 0, we're stuck at about -2.5, I think, on your example that you've given me. But if it was stuck at 0 and the upper limit fell below 1 and the lower limit fell below 1, your measurement system can only actually be in 3 places. Either dead on 0 or at 1. In other words, out of control on the top limit, or the other way, down at -1, out of control on the bottom limit. Now that measurement system just isn't going to work on that control chart, because unless you're dead on the nominal, the chart's going to say you're out of control. That chart is too sensitive because you don't have enough decimal places. If this was split up into 10, as it should be, you'd have potentially 20 possible results. Everything would work okay. All right, so that's when you'd get a problem. Now you don't have that. What you're telling me is your natural window of behavior, so let's put the chart up here, is if I calculated it, the lower limit could fall at around about -15. The upper limit could fall around about +5. Got the average going through the middle here. But you've got, of course, what's known as discrete categories. And you've got 20 of them. Now 20 discrete categories is more than enough for this to work perfectly okay with the IMR or the X-bar R. Discrete categories is normally a measurement system rule, and they usually say 5 discrete categories is the minimum. Why 5? Because if you wanted to draw a histogram of your continuous data, five columns would be the minimum you'd want to see. If you have less than that, so if you think, if I've only got 3 columns, I start to lose the normal shape. I'm not seeing what's going on. So when they talk about distinct categories, the reason they say 5 distinct categories is because 5 distinct categories is the minimum to be able to see the distribution. Okay, so you've got 20 according to your measurement system, and that's where your process is behaving. So your process has the possibility of bouncing around in here in a random pattern, doing its natural behavior, not triggering unnecessary signals. This one here is clearly triggering unnecessary signals. It's going to make you overreact in this situation. Not enough distinct categories. You need an extra decimal place. So really this isn't necessarily a problem of SPC. This is a problem of measurement system analysis. If your measurement system has enough distinct, and I've put discrete categories there, apologies, distinct categories. If your measurement system has 5 distinct categories at least, or more than that, SPC is going to work fine. Your measurement system is fine. And that's the answer to your problem. So good news. Now the only reason I'm saying good news is because you say the machine goes from -15 to +5. So I'm assuming that's what the data actually does. I'm assuming the results fill that window. If your results are much tighter, like this, then of course the limits would be tighter and you'd start to suffer from that problem. But as long as you've got enough distinct categories, when you do an MSA, those 2 charts should be okay. There's your video. I will send you the link. When I send you the link, by all means, send me any comments back. For the rest of you, please subscribe, please leave comments. And if you have a question, please just leave a question in the comments on a video, and I will make you a video to try and help you with your process capability, your quality problems, whatever it takes. I look forward to hearing from you soon.